Now, what we're going to do is go through a procedure for solving story problems. And you might want to pause the video and so you can copy this down, or I'll read it out too. So here's the problem. We're going to use a procedure to solve this. Suppose it takes twice as long to drive from Vaughan to Albuquerque as it does to drive from Roswell to Vaughan. Suppose it takes twice as long to drive from Vaughan to Albuquerque as it does to drive from Roswell to Vaughan. So what we're doing is we're doing like a road trip. We're going from Roswell to Albuquerque. We're going to take the northern route. We'll go north out of town on the 285. We'll hit Klein's Corner, and then we'll drive west on I-40 until we hit Albuquerque. Now, if the drive from Roswell to Albuquerque, the entire trip, takes 270 minutes, how long did it take to drive from Vaughan to Albuquerque? So, how do we go about this? Well, the thing about a story problem is it's not always written clearly. In a way, a lot of problems in mathematics that we might encounter in the real world, they're not going to just sort of step forward clearly either, unfortunately. So what we're going to do is the following. We're going to use a procedure that helps us understand what's going on. And as we go through this procedure, hopefully get a stronger grasp. Now, there are lots of things we can do to help us understand. Making a picture, for example, is one way of doing that. In some way that kind of takes all the pieces of the problem and kind of puts them so they're accessible in our brain, and we can maybe find a pattern of what's going on. And sometimes drawing a picture and then looking at that picture, that'll do that too. So the first part of this procedure, and this is going to be somewhat like the example, what they say to do in the text. I'm going to follow mostly a technique I use in my algebra classes. But you want to read and reread, and this is what we're trying to do. As we read, we want to identify what is known. Now, known means it's a quantity that has a number attached to it. So we want to list what's known. So we might be told that a crate weighs 100 pounds. We might be told that it takes 2 hours to do something. There's a number attached. So those are known quantities. There's a number that goes with this quantity, or a number that goes with this object or concept or element. Now we want to identify what's unknown. Unknown would be an element that it's significant to the problem. Sometimes they'll throw stuff in there that really it has nothing to do with the problem. It's just a distraction. But there's something, it could be an element, say like another weight, like the weight of a boat, but they didn't tell you what that weight was as a number. It's just an element, an idea, but no number was there. So that would be an unknown. So for our problem of Albuquerque, what do we know? Well, not a whole lot. For the Albuquerque problem, we know it's 270 minutes from Roswell to, and I'll abbreviate Albuquerque as ABQ. It's the sort of the airport abbreviation. So that's what we know. Now, what do we not know? Well, there's two things we don't know. And it's the time. One of them is the time from Roswell to Vaughan. And the other one is the time from Vaughan to Albuquerque. We weren't given numbers for these. Now some of you might be saying, hey, hold on. We do know something about Vaughan the Albuquerque. We know it's twice the time from Roswell to Vaughan. And you're right. This isn't completely unknown. We just don't have a number for it. So this brings up something called unknown, something without a number, and fundamental unknown. So we don't have a number for the time from Vaughan to Albuquerque, but we do know this. Whatever it is, it's twice, whatever this time is. Oh, I'm sorry, let me back up. We don't know the time from Vaughan to Albuquerque, but we do know it's twice the time from Roswell to Vaughan. So this brings up the idea of a fundamental unknown. This will always be twice that. So which one's the fundamental unknown? Well, the fundamental unknown is the one that if we discover this, we automatically discover that. Now, to be honest, if you knew this, you could approach this in a way where you'd automatically know that as well. But the way we're reading the problem, maybe we're taking it as this. We were told that whatever this is, multiply by 2, and you automatically get that. So this one we know absolutely nothing about. We do know this is twice that, so we know something. We didn't get a number for it, but we do know it's twice of something. This one's a total blank. But we do know if we discover this blank, we automatically discover that. So it's the foundation of that. This is the fundamental unknown. And that's what takes us to step 2. So we want to figure out, what do we know? What do we have numbers for? What do we not have numbers for? And of the things that we don't have numbers for, is there one of these that if we did have a number, we would automatically know the other thing? Or to put it another way, do we know something about one of these unknowns while the other one's totally blank? We want to identify the one that's blank. That's the one that's our fundamental unknown. This one, we know a little something about it. Even though we weren't given a number, we know something. It's twice that. The time here is twice as long as that. So this one, no clue. So what we do in step 2 is we let the x equal the fundamental unknown. So for us, x is the time Roswell to Vaughan. So what we do, just like we take those objects when we were translating algebraic expressions or equations, let's call that object a variable. Now, you could probably call it t if you wanted to. T is usually used for time, but okay, we'll just go with x. Time from Roswell to Vaughan, we'll call that x. Now we're going to use those translation skills. The time from Vaughan to Albuquerque, which I'm abbreviating as ABQ, is twice the time from Roswell to Vaughan. Step 2 is about the unknowns. We call the fundamental unknown x, and then what we're going to do is write an expression or a little mini equation that describes the other unknowns in terms of x, describes the other unknowns in terms of the fundamental unknown. So what we're given here, the time from Vaughan to Albuquerque, that's a time. So we'll call this maybe t. Really great to call time t. is twice, what is it twice? The time from Roswell to Vaughn. Now, we already have a variable for this. We call this x. So now we have this. T is twice x. Or put another way, T, we do our translations, is the equal sign. Twice means multiplication by 2. And you can find that on that page 485. So T equals 2 times x, or T equals 2x. Again, in algebra, circle this, algebra, we make the multiplication sign invisible when there's a number next to an unknown number or a variable. So the key step in number 2, it's working with the unknowns. Identify the fundamental unknown and give it a name. We're going to call it X or maybe T or something. And so there we go. That's the time from Roswell to Vaughn. Then the other unknown, in this case, the time from Vaughn to Roswell, we were told that whatever that time is, it's going to be twice the time from Roswell to Vaughn. And so we come away with that. Step 3 is the equation. And what we do with the equation, there's something that brings everything together. There's something that brings everything together, our knowns, our unknowns. There's an overarching relationship. What is that? For us, the time from Roswell to Albuquerque, and I'm abbreviating that as ABQ, is 270 minutes. So the overall time is 270 minutes. So what's going on here? Well, if we're driving from Roswell to Albuquerque, we're going to drive through Vaughn if we're taking that northern route. So that means the time Roswell to Albuquerque, what is that equal to? Well, it's got to be the time it took us to go from Roswell to Vaughn, plus the time Roswell, oh, I'm sorry, Vaughn Albuquerque. Got to go from Roswell to Vaughn, and then we got to go from Vaughn to Albuquerque. And then this problem, that's how we're breaking it up. Now, let's fill in our knowns and our unknowns. This is the overarching relationship for this problem. So what do we know about the time from Roswell to Albuquerque? Well, that's 270 minutes. Okay, well, what about the time from Roswell to Vaughn? Well, we've worked with that in step 2, and we just called it X. That's fine. X is what we got. In this step, we're working with both the knowns and the unknowns. And finally, that time from Vaughn to Albuquerque, we call that capital T. Now, to solve an equation, if we have one equation, the only variables we should have in it Well, it's just one. We should only have one variable. So this one has two. There's an x and a t. But can we do something? Is there's a trick we can do to somehow turn this into an equation where there's only one type of variable instead of two types? And there is. T was 2x. That's why we want to express the other unknowns in terms of the fundamental unknowns. When we construct our equation, we'll have our known, our fundamental unknown, and then the other unknowns. We want to swap out the other unknowns for this. In this case, for us, it'll be 2x. In another problem, it might be something else, like 1.5x or something. But in our problem, it's this. So we're going to substitute or replace t with 2x. And when we do that, we have an equation with only one type of variable, and that type is x. So now we get to step 4. We solve the equation. So first off, for this one, we're going to combine some like terms. We have a single x, there's 2 more x's. So that means there's now 3 total x's. So this is really 3 times x. So we want to cancel multiplication by 3. What's the opposite of multiplication by 3? It's division by 3. So we divide by 3 on that side, goes away. But what we did on one side, we have to do to the entire other side. And we get this. So now we get 90 minutes is equal to x. And we usually say, all right, we're done. And to be fair, I mean, we've solved something here, but I'm going to circle it. What did the question ask for? This question, oddly enough, wasn't looking for x, though the find x is going to be absolutely helpful here. We need to do this. Remember what x was. It's the time it takes to go from Roswell to Vaughn. Well, apparently it takes 90 minutes. So what they asked for, though, was the time from Vaughn to Albuquerque. Now, having figured out x is 90, can this help us find this? And so one of the important things with solving for x, we're finding the fundamental unknown. Remember in step 2 that we came up with an equation that describes the other unknown that wasn't fundamental in terms of x. That other unknown was the time from Vaughn to Albuquerque. So that's why this is important. In step 4, we'll find the fundamental unknown, we'll get a number for it, and sometimes that's one of the answers they want us to find. Sometimes it's the answer they want us to find. But they might say, okay, I want you to go back. Now that you have the fundamental unknown, determine what the other unknowns are. So for us, we want the time from Vaughn to Albuquerque, and that time is going to be twice the time for x, the time from Roswell to Vaughn. So that means this unknown is equal to 2 times the fundamental unknown, excuse me. And then again, we'll replace x or substitute for x the number, I'm sorry, not 270, I apologize. What we discovered x to be. We found out x was 90, there we go. So 2 times 90, 180. And that's the answer we want. The last step in these, step 5, want to check our answer. So sometimes we want to check our computations. Did we not, hopefully we didn't make like a computational error, or when we're solving, we didn't make an algebra error. Another one, some of these problems require the use of formulas. We want to double check the formula or the model. Now for the model, that might be a picture that we draw to get a formula out of. And you might want to double check that picture. Does it make sense? Or, ooh, I drew this and I left something out and I got to deal with that. Lastly, does the answer make sense? Sometimes we can do all of our computations right. We're sure of our formula or model, and we still get an answer doesn't make sense, which could mean that maybe there could be something with this formula or model that's a little bit off. And that can happen. So we want to make sure the answer makes sense. So for time, usually with problems in time, you shouldn't be getting negative answers. It's not impossible. Some questions might want you to do that. But we usually think of time as being positive. So if you get a negative answer for time, that might be a concern. Another thing that could come up is, does it make sense in that if it takes, say, 90 minutes to go from Roswell to Vaughn, and it's supposed to take twice as long to go Vaughn to Albuquerque, and you think you've done everything right, and somehow you end up with an answer that's like 10,000 minutes. And 10,000 is more than twice 90 minutes. So that might be another thing to consider. Does the answer make sense? And that's really best we can do. Maybe if you know someone who, if you're working on a problem, say at work, double check all, especially like this one, make sure you're representing the problem and with all the pieces in there. Sometimes someone knows something that we don't and say, hey, you need to consider this and put this in there. So anyway, and our problem, it does make sense. 90 minutes, all right. I mean, seems about right. And then twice of that would be 180. And that's what we got for our final answer. And that is twice of 90. Well, the time from Vaughn to Roswell, we got 180, and 180 is 2 times 90. And that was the time from Roswell to Vaughn. And if you add these up, sure enough, you get 270, which was supposed to be the total time to get from Roswell to Albuquerque to begin with, according to the problem. So this answer seems pretty good. We got positive times. The relationship, the Vaughn Albuquerque time is twice the Roswell Vaughn time. Add them up, you do get the same total time. So this seems like a good answer. So that's the introduction there. Any questions, let me know.